In this video, I'm going to look at a TPA3116D2 120 watt per channel Class D Bluetooth audio receiver. And I'm going to show you a mod to increase the Bluetooth range, and we'll put it through its full paces, including measuring it on the scope and checking it out for power output and for waveform distortions, coming right up. So Banggood.com sent me this to evaluate. The unit is based on a TPA3116D2 chipset. It uses a Bluetooth module BTM835, CSR 8635, and it's a 4.0 Bluetooth specifications. They claim a distance of 10 meters. Well, we'll see, but I think we can work on getting that thing a little bit higher range than that. In fact, I'm going to show you how to do it. The input voltage, 12 to 24 volts DC at 3 amps, and that'll give you 120 watts times 2 output at 24 volts with an efficiency rating greater than 90%. And we're going to put this thing through its paces. I'm going to pair it to my phone, and we'll hook it up to some speakers, and we'll try it out and just see how well this thing performs. And then what we'll do is we'll put the scope on it and take a look at the waveform and take a look at how clean the signal is. First things first, though, we have to connect the speakers. Now, this is a balanced output, so you need a dedicated wire for the positive and negative. You cannot use a common ground, as some systems do. So keep that in mind, that you need to hook this directly to your speakers. You can't go through speaker switches and so forth like that, because a lot of those speaker switches, they'll actually bridge all of the negative leads together, and well, that would cause amplifier failure. That would cause a short circuit on the negative lead. Now, of course, how this works is, as one inductor is producing the positive going signal to the speaker, the other inductor is producing a mirror image, a negative going signal of a mirror image of that audio waveform, and then they reverse when the phase reverses. In effect, it doubles the amount of power, or doubles the amount of current or voltage available to the speaker terminals than you would normally have if you only had a single-ended output. You gotta play, pause, and it looks like it says reset. Skip back and probably volume down. Skip forward and probably volume up. And a DC 12 to 24 volt power inlet. Center tip positive. So I have a 12 volt power supply. We'll plug it in. Okay, I take it it's searching for Bluetooth. So let's do a scan and see if I find it. Let's see how easy this thing is to make it work. So Bluetooth, I'll tap on Bluetooth, and we'll see whether this thing will find BT speaker, Bluetooth smart device. Let's try the BT speaker, see if it will pair. Do I trust the BT speaker? Yes, I'll trust it. Look, I think I've paired it. Let's see if it will play some music. And now the light's flashing blue to indicate that it is paired. So let's find some music on this thing. Music, there we go. It's probably going to blow me right out of the shop. It's probably cranked up full blast. And we'll just press a button to play. I could probably do it on here too. Oh yes, I can control it on my phone too, right? I can control the volume from both and play. I won't be able to leave this running because I'll get hit with copyright. I'm going to listen to it for a few minutes here myself. Now, how it works, if I just tap the play pause button here, obviously it will stop it from playing. If I play it again, if I tap the forward button quickly, it's going to move to whatever is next. And I've just got my phone set in random play, so I can control it from the board here. And go back, And if I press and hold the button, it'll increase the volume. If I press and hold, it will decrease the volume. On the phone, if I tap my button, I think on the phone if I tap it, it changes. Yeah. If I tap it, it changes the volume. So I can play this one. I can play this track. This is royalty free, so we'll listen to this one. I'm going to take this thing, walk away with the phone, and just see how far I can get before it shuts off. Well, as you can hear, I didn't get very far. I didn't even get to the door. That's terrible. I'm now out in the driveway, and it's very spotty. Now, I didn't get very far. That was, I was expecting to get a little further than that. But this is the antenna here. What if we look at this thing's sitting right on the back of a ground plane here. So that is certainly going to affect the range. But you know what? If I attach a piece of wire to this and extend this antenna a bit, I bet you I can extend the range. So let's try that. Let's just turn on the soldering iron, and I'm just going to solder a piece of wire to this antenna, and I'm going to make my own antenna out of just a little short piece of Cat 6 solid wire. Let's see how many thumbs down I can pull on this one by soldering onto this thing without powering it down, because I like taking chances. So I'm just going to tag onto the end of the wire here. That's just a copper trace. This is the side that goes into the board here, so I'll just tag onto the end of the wire here. And I have a little piece of copper wire, and I'm just going to stick it up there as in a little antenna. And then we'll start this thing playing again, and we'll see how far I can get. Just going to bend this over like a little foot, so I have a place to tack it down to. The formula for a half-wave antenna is 468 divided by the frequency, and that would give you your length in feet, so you would divide that number by 12. Works out at 2.45 gigahertz to just a little bit over 1.5 inches in length. Okay, now we've just created an external antenna. We'll start it playing again. I'll see how far I can get. That certainly makes a huge difference. For the heck of it, let's just try a big wire and see whether a huge wire makes a difference anymore. It'll probably make it perform less, but let's just try it. Okay, now it's got a huge wire on it. Let's see whether I can make it across the street as far as I did with the 1.5 inch wire, which is approximately cut to half a wavelength. See, having a huge wire on there didn't make any difference, or it didn't improve it at all. In fact, I think it probably was a little bit less. So we know that if we just put a short little 1.5 inch piece of wire, that one worked the best. You can test it again, make sure it still works. little bit of fun with this thing, and we'll just take a look at what it does on the scope. This being a Class D PWM amplifier, we should get, and it's got some pretty good size inductors on this thing, because this amplifier is rated at 120 watts per channel. So it's a, it's a pretty powerful little unit here. I can't take the heatsink off on this one like I did the last one. It's not bolted down. It's actually attached right to the top of the chip. So I can't see what chip is in this thing, but these things all are going to work the same. So I just got to find a point to ground my scope to. Taking a closer look at the board, there's actually a header on this thing for connecting external audio sources. I wonder if this is going to have an audio out on it as well. Wouldn't that be interesting? So let's just, first of all, let's play some music here. I'll just play something else from royalty free. That will work. And let's just take a look and see whether there's any audio here. I would say that that is affirmative. I'm definitely going to have to play this track through this thing on my big speakers in the house and just see how this sounds, because I know how this track sounds. That opening there with the basses at the beginning of that track literally rattle the walls. It is unbelievable. This is this is a full orchestra obviously playing this. This is the Music Bakery, right? This is Jack Waldemeier, and it's an orchestral piece that he did. And yeah, the sound quality on this track is just unbelievable, and it rattles the walls. And I've listened to this a few times at a good level, and yeah, it's had the windows shaking. So I'm gonna have to hook this thing up to some half decent speakers. These little crappy little Centros radio scrap garbage things aren't gonna do it any justice. So I kind of like to see what this thing performs like. But as you can see, there is an analog output, and I would imagine that if we fed a signal into that, which would not be too difficult to do, it would also be an input to the amplifier, because it's just going to take the audio signal from the Bluetooth receiver here, and this is the signal path going to the digital amplifier. And here's our output filters over here. So let's take a look at the waveforms on the output filters. So if I tie in here to one of these outputs here, of course we're going to have to bring this down here because this is operating at about 400 to, let's say, 400 kilohertz. Let's hit the auto button on this thing, let the scope figure out. There's our waveform. Okay, I don't need the second channel here. We'll just turn that one off. So here's our output. It's 403 kilohertz. Of course, as they increase the volume, you will see the width, the pulse width will change. Then of course back to our normal 50-50 duty cycle of your pulse width modulated output. Even when there's no sound, there's going to be an output here. Now, is this going to actually shut the signal off when there's no sound? That's interesting. I bet it does. I think it just did. Yep. So that's exactly what it does. When there's no output, it actually cuts the sound off to go into energy saving mode, which is exactly what Bose does on the sound system in the Volt. And when they promoted that, they said it was a new digital amplifier that saves energy by going to sleep when there's no sound, and this one does exactly the same. I should actually try that on that other one that I've still got sitting here and see whether it idles, or whether it actually shuts down. Of course, if we go to the other side of the coil over here, the inductor, this side here, when I play it, this will have the actual audio signal on it. And I'll have to, obviously, to see that, we'll have to turn down. Let me assure you that goes bloody loud, and it's not going to show off on camera. It's not going to show up on camera how loud that went, but I guarantee you can hear that at the end of the block, because that was, even though these little tiny little speakers I've got here, these things, that was loud. And you can see the distortion when I cranked it up, right? We got into the distortion there, but yeah, this thing actually performs well. It's at 403 kilohertz is the oscillator for this one. So 12 volts. We're running it on a 12 volt supply. The input on this says 12 to 24 volts, but I do see that it does have an onboard 12 volt regulator, so I don't know whether the voltage would be higher on 24 volts or not. It might. That regulator might be for some of the other circuits, and the rail-to-rail may be higher on a 24 volt input. I haven't tried it because all I have is a 12 volt supply here. It takes 3 amps. I'm running it on a 2.5 amp supply, I think now. Yeah, this is a 2.5 amp, just a switching supply that I'm running it on. But even on that, it sounds pretty good. What do you guys think? Should we put 2 power supplies back to back and feed this thing with 24 volts and see what we can get out of it? I think we shall. Okay, we've just soldered down 2 12-volt supplies in series. I've put the power on here, and this should fire up into... There we go. It is now paired. We now have 24 volts on here. Let's take a look at what our output is on this thing. So let's hook up the probe. Obviously there's not going to be any output right now because I don't have anything playing, so we'll start something playing on here. And well, it's already louder, I can tell right now. So it looks like we have our full 24 volts output now. We take a look at our rail to rail. Gonna center it here. We're on the 5-volt scale. So 5, 10, 15, about 20 volts now is what we're looking at. So the fact that we've doubled the voltage, that means that our voltage swing can be double what it was before. So that means we should be able to get some more volume out of this thing. Let's try it and see. My neighbors aren't going to be too happy with me when I crank this thing up, because this is going to go pretty loud. As you can certainly see there, we're pulling full rail to rail, 23 volts peak to peak there on that output. That's pretty impressive, and yes, it is louder, as loud as I thought it was before. I can definitely tell you that that was substantially louder. Now I'm only feeding this thing with 2 little crappy power supplies that are only rated at 1.6 amps each. So I'm giving it 1.6 amps at 24 volts, and this thing is just rocking. I can't believe how loud this thing goes out of these tiny little speakers. It's really quite impressive, and if I didn't test one of these things, I would have never believed that type of performance you can get out of a little board that only costs $23. Unbelievable. Hey guys, if you're looking for something, check this thing out, because this is the real deal. And you know, I know I'm going to get the haters that are going to say I'm doing a commercial for Banggood. I'm not doing a commercial for them. They've sent me some products to evaluate, and I'm giving you guys my best opinion of whether I think it's any good or not. And this is another winner. This is another little board that I definitely could recommend someone to buy. You know, even at twice the price, it would probably be a pretty good deal. It's great. Now, to get range out of it, you're going to need to do this to it. Okay, you're going to need to put a little antenna about 1.5 inches long on it. But I got all the way out to the street, which is a good from here, and this is in my workshop. So the front door of my shop is 30 feet back from the road, and I'm another good 10 feet back, and I was across the street before it really started getting bad. So I was a good 50 feet. Good 50 feet from this receiver. And there's a bunch of stuff. There's a TV, there's a couple TVs sitting in the way of my car. This thing, with the proper antenna, this thing actually performs well. So that's the only thing I can say. If you buy one of these boards, put a little antenna on the thing. It doesn't have to stick up like this. You can tuck it along the side. If you're going to mount it in a case, you can tuck it out of the way. And yeah, feed it with 24 volts and it will be very happy. even 12 volts it'll be happy, but it's happier on 24 volts. I hope you enjoyed this video. I've got another one that I'm going to be testing real soon, and I could actually even test this one again on 24 volts. This is the 50 watt per channel. This one's rated 120, and you can see the difference in the size of the inductors on here, right? Much bigger inductors, much bigger capacitors on it. This one actually sounded pretty good though for 50 watts per channel. This one's 120 watts per channel, and I have a mono Class D amp that I'm going to be testing very soon as well. And well, we'll see that one soon. Anyway, that's enough for this one. This video's gone on far too long. Hope you enjoyed this. We'll catch you in the next one. Bye for now.